Hey guys, welcome to the first screencast of BIM Collaborative. In this screencast, I'm just going to go quickly over how to do basic piping systems and plumbing. And just to give you a little bit of background on who I am and what my experience is, I have over 15 years, almost 16 years experience in the engineering business, doing mostly plumbing, piping engineering, um, but I also have some HVAC experience and some electrical experience. So I think I have a decent breadth of knowledge, at least on how to do a project and engineer a project and create really good looking engineered documents. And my experience, of course, like all of us, if you're if you have 15 years plus, you've probably started on AutoCAD, and now this move to Revit is a big jump for a lot of us, and it's making us think differently. One thing that I missed out on was I went from AutoCAD 2007 and straight to Revit about 3 years ago. I never did touch AutoCAD MEP, which, if some of you did, you know that it has a lot of the characteristics that Revit does, like parametric objects and 3D drafting. But my first exposure to the 3D world was Revit. So I got thrown into using Revit exclusively at my last company because they wanted to move to Revit, but they actually didn't take the time to learn it. We had to actually learn it as we were going. And I think that kind of forced me into a unique situation where I had to meet project deadlines, but also had to learn um, how to use Revit and how to overcome a lot of the obstacles that you might find as you're learning Revit. And I think I found some pretty interesting tips and tricks that hopefully can help you guys. Um, but where do you start? If you have a decent amount of Revit experience or at least some foreground in it, background, I'm sorry, in Revit, then you probably do know how to create some simple systems, how to do some routing, pipe routing, HVAC duct routing, electrical conduit, wiring, things like that. But what I'm going to concentrate on this first screencast is how to set up your piping systems and how to basically name your piping systems and use your tags to descriptively name those or tag those pipes. And this may be something that you know about already, but hopefully there's a couple of little things that I can cover that you may not have seen. One of the things I noticed about Autodesk products in general and Revit especially is that there isn't really a lot of material out there. You can Google different problems that you might experience with Revit along the way, but it's rare that you'll actually find a really good answer. Um, a lot of the answers that I've had to come up with are things that me and my colleagues discovered on our own. So anyway, let's get to it. Here I have just a basic plumbing project. Um, Not much to it, but this is a good starting point. So you can see that what we did is we actually copy monitored these plumbing fixtures into the project. You can see that they're actually families now in here without any link to the original model. Just to show you what happened, I deleted that one. I'm going to actually copy monitor this fixture and just show you that it actually is really a 3D. Um, it actually really is a 3D object. But what we did is we have found that a lot of times, well, let me go back. We found that copy monitoring plumbing fixtures really can be problematic because plumbing systems are so finicky as far as like where fittings are placed and how routing is done, that if the plumbing or if the architect came back and actually moved fixtures enough, it could pretty much destroy the system you'd already put in place. And that's one thing we wanted to avoid. So what we actually did, and now that I'm doing this, I'm going to go ahead and go all the way with it because I need to show you everything. I'm going to delete what was already, I'm not going to delete the floor drains because we put those in. Um, we'll delete that. All right, so what I'm actually going to do is I'm going to copy monitor all of these, but then I'm going to drop the link so that we are no longer monitoring the position that the architect gives these fixtures. And when they do come back and make changes to the location, it won't mess with our piping layout. Just thinking a little bit here. Um, it's really important. We had projects before where the plumbing fixtures changed enough that it actually, when you're using slope piping, especially because slope piping in Revit is very, very finicky, and if you were to change the location of one fixture, it might actually force um, the piping to go non-sloped, which is really, really annoying. And sorry for the warning sounds. I probably should turn that off for the next screencast, but there we go. Those are all that I'm going to copy monitor for the moment. Now I'm going to select them all the ones that I've copy monitored, and I'm going to actually stop monitoring. So what that has done is that it's created an instance of that family in my plumbing model. As you can see at the top of the screen, this is called B912_plumbing. So this is actually my model, and these families are a part of my model now. They are not dependent on the architect's model. The one thing that you have to be careful with now that if you were to follow this approach, is that you would need to consistently uh, check your fixture locations with the architects. But this actually gives you the freedom now to make your changes without uh, automatically destroying the piping system that you've put in place. All right, with that said, let's go ahead and start creating a piping system. And now, where does a piping system actually originate in Revit? Now, domestic water is a little different than sanitary. The workflow is different. And what I mean by that is that sanitary actually rolls out from the farthest fixture to where you're going to bring the piping out of the building. And if I were to actually start from where the piping comes into the building, I may find myself too far above the invert of the fixture itself. So what I'm doing is I'm actually starting some sanitary waste piping. I'm going to slope this up because I'm starting from where it comes into the building. And this is just to give you an example. I just said that you wouldn't want to do this typically, but this is just to give you an example of what may happen. And I'm going to basically center that piping to the chase somewhat. Now keep in mind this model may not be realistic, but it is a starting point. And I just realized as I made that deletion of the fitting and spread those apart, this is one of the problems that you may run into with slope piping. Because I deleted that, and if I were to pull this back and I wanted to do a 45 to that piping. Now see if I select the piping I created here, you can see that the sloping is at 1/8 inch. Select this piping, which is disjoined from the rest of the system, and you can see that that's at 1/8 inch. It's a little difficult to see because of the wall, but there you go. Now, if I were to trim these two together, look how the sloping changes. The sloping changes for this part because it's actually having to change different parts of the pipe and maintain a connection to it at a certain slope, but it can't keep that here. Now if I can actually select this, well, usually you can. I can change the slope of this to 1/8 inch and see, excuse me, I get that warning. The slope that you've specified cannot be applied to this pipe, and that's because we've separated them too far to actually maintain that slope. Now, I don't want to waste a lot of time with this, but that's just to give you an idea of how different the workflow is for sanitary than it is for domestic water. So let's actually start the way you're supposed to start. With sanitary, you would typically start at the fixture. You could for domestic water as well, but I tend to find that domestic water works better working in the opposite direction of sanitary. So we're going to start from the family. Now let's actually look at the family and see what connectors we have available to us. We should have one sanitary discharge from the fixture. And as you can see, the architect was so unfriendly as to not actually give us any connectors whatsoever. So what I'm actually going to do is I'm going to create my connectors. But before creating our connectors, we actually need to give it a face to draw the connector from. And right now, you may think that we would have some kind of face to connect to, but let's see if I do a piping connector. You notice now he has not actually given us a really good face to give those connectors to. So what I'm going to have to do is I'm going to have to create the face for those connectors. So I'm going to go to the reference level view of this fixture, and our drain outlet would actually be, what I've done is I've started an extrusion. I don't want this to be a very deep extrusion. It's just there for my connector, so I'm going to make it at 1/8 of an inch deep and the offset at 0, 0. And I'm making a circle. I'm going to just place it near about where I feel like the connector to go. And I know that I want the diameter of that connector to be 3 inches. So I'm going to set my radius at 1.5 inches. And there we go. We have a 1/8 inch deep, 3-inch diameter extrusion. And let me just show you what that looks like. So if I go and I turn around, you can see that now we have an extrusion that we can connect to, and it's sitting inside the model that they'd already created for that fixture, so it works out. I didn't mean to hit that. So now I'm going to create the connector for it. So I hit pipe connector under create. Let's create, go to pipe connector, and then I'm going to actually select that extrusion. You see how it lights up? When I select it, then it gives us this connector. Now I go to our properties panel, and you can see all of the different properties that are assigned to that connector. And what we know that we are going to do this system. This is going to be a sanitary system. So I set our system classification to sanitary. Our flow configuration will be fixture units. We know exactly what fixture units we're going to assign to a water closet. We want our flow direction to be out. Loss method, I'm not going to mess with that with sanitary. We're going to set our fixture units. This is a flush valve type water closet. So our sanitary fixture units will be for public flush valve type water closet, and that's at 6 fixture units. The diameter of the connector should match the diameter of the extrusion. I typically will make my extrusions the same size of the pipe that I'm going to connect to it, and then I need to make sure that my connector is that same size. So I'm going to make the diameter of that 3 inch. And you could also give that connector a description, which I'm going to do. I'm going to say sanitary, can't type, sanitary waste out. And we'll apply that. And now we have a connector to connect to. And I'm just going to deal with sanitary for, I'm just going to deal with sanitary for this screen test. So we're done with that connector, and we can now load that into our project. Or overwrite, I'm going to go ahead and overwrite the existing version and its parameter values, even though I haven't actually changed any parameter values. I just know that the family I was just working with directly has everything in it that I want. Now you see it updated every fixture. Now you see that extrusion. And if I were to go to 3D, well, actually, I don't want to look at that version. Well, I'm going to turn off the link so we just see the plumbing. Now you can see, now that that connector is there for each of those fixtures. And it gives this little sign of a trap showing that it's sanitary. It tells you how many fixture units are out. And it also tells you, if you look at your properties, what system classification that is. And you know that because we just created that in the family. So now we know that we have a sanitary pipe or a sanitary connector on that family. So I just hit Control Tab to go back to my original view. I'm actually going to hit the X up here to close out any other views. I hate I hate looking up here and having so many views open, so I make it a habit to hit the X as much as I can to keep my views kind of clear, so that I know I can control tab between the ones that I'm actively using. Um, for example, I want to keep the 3D and the floor plan view open, and actually I just want to set this to fine so we can see the pipe. Now you see that the pipe is way too low. Um, I'm going to leave that alone for now. But anyway, so you can see that now I can control tab back between the only views that are open. Um, so I'm actually going to delete that pipe. We're going to start from the fixture. Now there's a couple of ways to start drawing in Revit. Um, I found that once you actually get used to using Revit and thinking in 3D, which you should eventually, and actually very quickly, surprisingly, um, you actually want to start drawing in this view as much as you possibly can until you actually have to switch to um, the 3D or elevation view. But to begin with drawing in Revit, I actually really had to start thinking in 3D because it was something that I hadn't done yet. So um, I'm going to create an elevation view. And I went to view and I hit elevation. And what that does is it brings up this little symbol, and you can change the way that looks. I'll show you how to do that later, but I want to rotate this view, and hopefully you guys are familiar with how these work. But the little arrow, if you click on the arrow, it shows you the clip area for this elevation. And now what this means is that this blue line out to the dotted line is the area that you're looking, and the direction that you're looking is it's like you're standing here on this line looking this direction. So I only want to look at those two water closets. So excuse me, I'm going to move this line here. I'm only going to look at these two water closets. So if I right click on the arrow, you can actually double click it as well, but I just want to right click on it. I do want to show you that we are on the right level. This building, the level for the floor that we're doing this work on is actually on what they're calling level 3, which is weird, but that's where it is. And I will take that back. I cannot show you the levels right now because um, this template was not set up to show levels very well. Now, what I was saying before about how this isn't a very realistic model, you can see that the architect really hasn't given us very much room for piping. 2 inches. That won't handle our fittings. So anyway, back to creating a system. Okay, we are going to start a pipe. And actually I want to be in fine view so that you can actually see the pipe. And the pipe type is called sanitary waste. Now, how did I get that? If you go to your project browser, go down to your, go down to your pipes, pipe types. You'll see that you have all these different pipe types. Now, some of these I've created. You may not see these in your default models, and I think, in fact, you will only see standard and maybe chilled water in your default models out of the box templates. What I did is I actually took one of the defaults. Standard is a default, and what I did is I duplicated that. You can right click on it, then rename it, and we'll just call this sanitary waste for screencast. Okay, and then I'm going to double click. I need to turn those damn sounds off. Anyway, I double click on it, and we can go and change our routing preferences. I want this to be schedule 40 PVC, and it is not actually in our list. Actually, yes, it is. All right, polyvinyl chloride. We're going to